Now we look at something about the refraction, which we have already seen the definition part. So refraction. So whenever I think of refraction, I have given the definition that refraction is nothing but bending of light. Bending of light when the light ray travels from one medium to the other medium. The phenomenon of bending of light when the light travels from one medium to the other medium. Here the various things we are to make a note in this particular concept is, every time we are measuring the angles with reference to the normal. So let us suppose a ray is incident like this, and whenever it is entering into the second medium, so let us say this is the rarer medium is lighter and this is the denser medium. As an example, I said rarer medium is air and denser medium is water. Then it will be bending towards the normal. So if at all I look at, this is called as refraction angle and this is called as incidence angle. Angle I is greater than angle R whenever light enters from rarer to denser. So rarer to denser. Unlike this, if at all light enters from denser to rarer medium, this is a thing which we have already seen. Just for the recap, I am just doing this. And here, whenever the light incidents, it gets away from the normal. That means I is going to be here, R is going to be here. Here angle I is less than angle R. So whenever the light ray travels from denser to rarer. So here one thing you need to remember, in both the cases the light is deviated from its original path. So the undeviated path is going to be this. If no medium is present, if medium is not changing, then it would have traveled in this direction. But because of the difference in the media, then it is bending towards the normal. Here also the same thing. If at all there is no variation in the media, then it would have gone in this direction. Because of change in medium, it is just deviated away from its original path. So the thing you need to remember here is, in case of rarer to denser, it bends towards the normal, and in case of denser to rarer, it bends away from the normal. And here one more point you need to remember, this segregation, the medium, can be denoted with the help of a parameter called refractive index, and this is what the definition we have seen, refractive index. So refractive index can be defined as the ratio of velocity of light or speed of light, the ratio of speed of light in vacuum to the speed of light in medium. This is one definition of the refractive index. This is how the refractive index can be defined. This is one thing. And next, the refractive index can be defined in many other ways also. We'll just look at in due course of time in what other ways it can be defined. And the refractive index, since it's a ratio, no units, mu has no units. So it is simply a ratio. So it has no units. See here, this refractive index you can also define in terms of incidence angle and the refracted angle. So whenever I look at that refractive index in terms of incidence angle and refractive angle, we have one popular law called Snell's law. Snell's law. So this is one of the important laws associated with the refraction. So according to this Snell's law, refractive index of a medium with respect to refractive index of a medium with respect to another medium is a ratio of sine of angle of incidence to the angle of incidence to the angle of refraction to the angle of refraction. So this is the definition of Snell's law. So it says that refractive index of one medium with respect to another medium is a ratio of sine of the angle of incidence to the angle of refraction. So when you look at this, you can just look into the case 1, that is mu, refractive index of the second medium, that is, this is the second medium and this is going to be the first medium. Refractive index of second medium with respect to first medium. So this should be pronounced as refractive index of second medium with respect to first medium, and it should be represented, it should be pronounced as mu is given by sin I by sin R as per the definition given. So here you can define the Snell's law as it is a ratio of incidence angle, sine of the incidence angle to the sine of the refraction angle. So this is how you can define the refractive index. So this is the first way of defining, this is the second way of defining. This is called as the Snell's law. And here this refractive index of second medium with respect to first medium. So in general sense, mu2 divided by mu1, this can be written as mu2 divided by mu1. So sin I by sin R. So here in this case, if at all I consider the first medium is a rarer medium, it can be a vacuum or air, refractive index of air, refractive index for air is going to be 1, for air is equal to 1. In that case, you will be getting refractive index of second medium with respect to air, that is given by sin I by sin R. This is a general sense. We always mention the refractive index with reference to the air medium or the vacuum. That is the reason the general representation of the Snell's law is like mu is equal to sin I by sin R. This is what the Snell's law. That means this is the second way of representing mu. Now one more point you can remember here, the refractive index is a function of velocity, and further velocity is a function of nu lambda. This is one formula we have from our wave theories and all. So velocity is a function of frequency and wavelength of the light. That means whenever the light enters from one medium to the other medium, the frequency does not change but wavelength changes. That is the reason it can also be written as a function of wavelength. Refractive index can be given as mu is equal to lambda 1 by lambda 2. That means lambda naught by lambda in this case. In case of this, instead of C you can write lambda naught by lambda. So this is one more way of representing the refractive index. That means the refractive index changes with respect to the wavelength, which means the color. So as color of the light vary, the refractive index will also vary. And how it is going to vary and all we look at, and we look at few more points with reference to the refractive index.